Hi everybody, welcome back to the TETRIX RoboBench video series. This is Tim, and today's another good day for me because I get to tell you about something new. And what I'm going to talk to you today about is one of the new things that we've come out with for TETRIX Prime specifically that's going to allow you to integrate this with some of your LEGO MINDSTORMs. So this is the EV3 module for TETRIX Prime. Now it's going to come with several things in kind of a system, but I want to start with the main thing, and that is this little electronic module that's going to actually allow the EV3 Brick to talk to the power components on the Prime system. So that's going to be the main thing, but it's got other things that come with it as well. One of them being an additional Prime connecting piece that's going to let the LEGO building system integrate with the metal building system. And I'll show you a little bit more about that in a minute. And then most importantly as well, a Prime DC motor. This is a DC motor, not a servo motor, but it's in the same form factor as our servo motor. And again, I'll show you a little bit more about that in a minute. But one of the things we probably want to initially establish is why would we do this? And that's pretty simple in a way. It's that when we build robots and we always want to kind of push the envelope and push ourselves to create more and better and bigger and stronger and more sophisticated things, sometimes we need to combine two systems. So that's kind of what we've done here is we've enabled you to actually combine your MINDSTORMS building system with the TETRIX Prime building system, hopefully maximizing the strengths of both and minimizing the weaknesses. This is all about real engineering challenge and actually taking two different systems, marrying them together, and come out with a better, more complete system from the two. So that's kind of what this is all about. So let's go ahead and talk for a minute about how you can get all of this, because that's going to be very important for you, we hope. And first, let me say that we talked about the individual components. We can buy each one of those a la carte. So you can go to pitsco.com, again, www.pitsco.com, and you can buy this by itself. You can buy the Prime DC motors by themselves. You can buy the beam brackets by themselves. But you also have the option of going ahead and getting kind of an all-in-one if you want to make sure you get everything you need to be able to use this with your EV3 Brick, and you can get our EV3 module component set. This is available online, and kind of a convenient way for you to get everything that you need. So let's talk specifically about how this is going to connect to your EV3 Brick. First, let's go ahead and look. It does have an EV3 style of connecting jack with the offset tab on that that's going to connect directly to an EV3 sensor port. Now note that I said sensor port, so that means it's going to take up one of the 4 sensor ports that you have on the EV3 Brick, leaving you 3 left. But it's going to allow you to control via that sensor port up to 6 different servos from Prime and 2 DC motors from the Prime. So it has an on and off switch that is going to allow you to access the 6-volt power system from the TETRIX Prime system that will power all of the TETRIX components. It is independent from the LEGO power system, so you've got 2 different power systems working there. There are software blocks that are available that we've written that will go right into your native EV3 programming language. So this is something that you're not going to have to relearn your software language that you're using. You're just going to add the extra mechanical components. So that's really very important for you. This can be then a scaled type of progression as you use this in the classroom. You're not going to have to jump right in and learn everything new. You can kind of add things in bites. There are 2 different programming blocks that are part of this. There is a servo block that is going to access all of the servo functions of the standard servos. And then there's the DC motor block that's going to actually output to the DC motors. So that's going to be huge for you within the programming environment itself. And again, we've written those so that they look and feel just exactly like the normal EV3 program blocks that you're used to. So they should be very intuitive and easy for you to integrate. So that's the programming side. And then from the building perspective, we've done some things with the beam connector. And again, I've got one of these to show you. This is an example of the beam bracket that fits right over the TETRIX Prime beam. And I've got a couple examples to show you of how that works. It'll fit over the beam just like that, kind of encloses the beam, and it will connect with either the quick rivet, just like that, anywhere along the beam. So I can put that anywhere along the beam on any of the sides. just like that. And then the quick rivet will fasten in just like that and fasten it in place. Or we can use the thumb screws and wing nuts. So you've got two different options of how fasten this piece to the prime beams, and then the Lego style components will actually connect to the beam bracket versus the regular connector peg. So it fits right into that as the connection between the metal building system and the plastic building system. And then let's talk a little bit more about the prime DC motor. Again, this is a major component that's part of this, because one of the things if you're programming autonomously on robots, servos can be a little bit finicky to use as motors as far as getting continuous motion through like a continuous rotation servo. So we actually thought it very important to create this DC motor. It has the same form factor as our prime servo, and you actually can mount it in the same mount. So you see I've got one that's mounted up already, uses the same actual servo mount, just like you would mount up a servo, connects the same way to our TETRIX Prime beams. So again, we're not relearning everything that we from scratch. We're using some of the things we already know how to do within the building system. So that's very important. So those are the individual components, just in a little bit of a broad format. So like we always want to do, we want to show you how that works together. So I'm going to bring a robot over and we're going to actually show this in action. Okay, so let me kind of give you a layout of what we've got here. I have a prime robot with the EV3 controlling it. Now this robot is from our EV3 curriculum that we've got that will go along with this whole thing. We're going to do a separate video to kind of explain all that, but this is one of the getting started robots from there. We call this the sweeper. The reason being that it's going to actually follow this line, and when it sees obstacles in the path, wherever they are here, it's going to knock them out of the way and continue on until it sees the red target at the end, and it's going to stop. So I'm going to go ahead and let's get this started so we can see how it actually works and see one in action. So again, you can see the robot actually followed the line, came to the red target, knocking the cups out of the way as it went down the line. So that's an example of using the EV3 as the controller, EV3 sensors to actually sense the environment, and then a combination of the TETRIX motors to actually drive the robot, and then the Lego motor to power the sweeper. So a fairly good integration between the two systems. Again, maximizing the best things of both, minimizing the weaknesses. So let's talk a minute about the mounting, because this is one of the things that I really like about this, because it's a very real world type of an example of engineering. We not only have to think about mounting the module, and let me show you just a quick minute how that works, because there's cross-axle holes that are in the case of the EV3 module that will accept either the Lego cross axles or the connector peg with cross axles. And then we can actually integrate them with the regular Lego building components, just like you would any other Lego component, with the connector pegs working just like they would in anything else. However you would connect the rest of your Lego building system. So that works exactly like the rest of the Lego building system. Makes that work really well. But you have to think about not just how it connects to the building system, but where, because it's very important for, because of the fact that you've got wires that have to go to different components, for you to have to think about in your engineering design, where do I put that so that it reaches all of the wires that it needs to. I've got DC motors I need to connect to, possibly servos. I've got to connect to the EV3 brick itself. So it becomes an important part of your design on where you actually place the module. And that's very real world. If you talk to any automotive engineer that has to design a hydraulic brake system, the routing of those brake lines becomes very important in where he puts everything within the system. So that again is an example of a real world type of engineering application. So let's go ahead and recap just briefly so that we kind of bring everything back together. We've got this EV3 module that we've created along with a connecting block that will integrate with the Prime building system, Prime DC motors specifically to work with this that allows you, again, to marry the two systems together and bring the best of both. We've got programming blocks that we've created that are free to download. You can find those at www.pitsco.com. That will go right into your EV3 software. They're intuitive and should match what you're used to within the program environment if you're already comfortable within the MINDSTORMS environment. So there's a very low learning curve there to actually implement this within your system. We've got an EV3 curriculum that is coming out that should allow you, again, to give examples of how this can be used in the classroom. And I think this is really going to allow you to go ahead and take your robotics to the next level and actually, again, learn to use two systems together and make everything work. So, like we always say, have fun, build some robots, come back and see us.